So now we're going to be looking at module 3. And module 3, it tells us a committee of 4 persons is to be chosen from 8 people, including Mr. Smith and his wife. Mr. Smith will join the committee. Mr. Smith will not join the committee without his wife, but his wife will join the committee without him. Calculate the number of ways in which a committee of 4 persons can be formed. So we need a committee, and you have 8 people choosing from it, you need 4. Now it's not just 4 choose 8, right? Because there are the different cases. So we need a committee of 4 people from 8, right? And so case 1 is that we can form the committee. So this is case 1. Case 1 is you can form the committee where Mr. Smith and Mrs. Smith are on the team. So Mr. Smith and Mrs. Smith are on the committee. So if Mr. Smith and Mrs. Smith are on the committee, I may not spell committee right, bear with me, not sure. So if Mr. Smith and Mrs. Smith are on the committee, then them 2 people that don't get selected, right? So already select them. So Mr. Smith is selected times 1 for Mrs. Smith is selected times, now that means I only have 6 people left back. So we're going to choose 2 people from the 6. And this would give us the number of ways we can choose a committee with Mr. and Mrs. Smith both on the committee. So to work out 6 choose 2, just gonna plug that in the calculator. So it's gonna be 1 times 1 times 6 choose 2. And that is 15 ways. So there are 15 ways we can select the committee if Mr. and Mrs. Smith are both on the committee. Then we can look at case 2. Case 2 is that Mrs. Smith will join the committee even without her husband. So let's look at Mrs. Smith on the committee. So if Mrs. Smith left on the committee, then Mr. Smith now joins. So Mrs. Smith, she put on, then, but Mr. Smith now go join, you know. Mr. Smith now go join. So look how I go do this now. Basically, I choose Mrs. Smith from them 2 people here. Yeah. So choosing 1, which is Mrs. Smith from the 2 people, times we're choosing 3 other people from the remaining 6. So choosing Mrs. Smith from them 2 people here, they were choosing 3 people from the remaining 6. So it's 2 choose 1 times 6 choose 3. So we'll do that now. 2 choose 1 times 6 choose 3. 2 choose 1 times 6 choose 3. That's a 40. So that's going to be 40. So we'll put 40 there. 40 ways Mrs. Smith can live on the committee. Then finally, there's a case where we can select committee members where none of them are on the committee. So case 3 is where none of the married couple, can I say none of the married couple? Maybe that's not grammatically correct, but I'm not sure. None of the married couple on committee. So if we not choose none of them, right? If we not choose none of them, we're not choosing any, 0 from those 2. We're not choosing any from the married couple. Then we're choosing 4 from the 6 people and we're left back. Yeah, man. So 2 choose 0 times 6 choose 4. We'll put that in our calculator. 2 choose 0 times 6 choose 4. We'll work that out. Okay, 15. That equals 15 again. So there are 15 ways. None of the married couple have not joined the committee. So therefore, the total number of ways then, the total ways is equal to 15 plus 40 plus 15. That is 70 ways. There's 70 ways we can select our committee of 4 people. Easy, soft, 70 ways. So we can just put that right here, that there are 70 ways we can select this committee. 70 ways. Nice. The next part says now 2 balls are drawn without replacement from a bag containing 12 balls numbered 1 to 12. Find the probability the numbers on both balls are even, then the probability the number on one ball is odd and the number on the other is even. So there are 12 balls. Cool? So let's do that around here. So what I'm going to do is I'm going to draw a box right now to showcase the 12. Let's say I'm going to put a little box here, and then I'm just going to cut it up in 12 pieces to indicate this is ball number 1, ball number 2, ball number 3, ball number 4, ball number 5, ball number 6, ball number 7, ball number 8, ball number 9, ball number 10. Yeah, man. So, oh, and a 10, 11, or 12. Yeah, 12 balls. So one more. Ball number 12. Now them say now, find the probability that both balls selected are even. We can do this 3 ways. Let me show you the 3 way them now. So look at this now. We need to find the probability that we select 2 even balls. 2 even. Now, to get 2 even balls, what that means is 2 even number balls. In order to get 2 even number balls, what we need to do is look at how many even balls are there first. 1, 2, 3, 4, 5, 6. So the chance of the first ball being even is 6 out of 12. After we take out the ball, so we take out this ball, cool? After we take out that ball, how many balls are left back? 11. 11 balls are left back. How many even balls are left back if we take out this even ball, for example? 1, 2, 3, 4, 5 are left back. So the probability of the next ball being even is 5 out of 11. So you work this out, and that would be the probability that you draw 2 even balls. 6 over 12 times 5 over 11. By the way, 6 over 12 is a half. So it's a half times 5 over 11. And when we work that out, we get 5 over 22. Soft. That gave 4 marks. Soft. With a capital T. Yeah, man, soft. That's method 1. All right, so let's call it M1. Let's look at method 2. Method 2 now is we can use combinations. The probability of getting 2 even ball, I'm going to write 2E to represent 2 even ball, or 2EB. To get 2 even ball, to use combination, that means you're choosing 2 even ball from how many even balls are there? 6 times how many odd number balls you're choosing? None from the 6. So 6 choose 2 times 6 choose 0. Can work that out. Oh, and then divide it by, because it's probability, divided by choosing 2 from 12. So let's do it using combinations now. And we're going to get the same answer. Yeah, let me just zoom this a little bit. So we have put in the fraction button first. It is 6, and we're choosing 2 even balls times 6, and we're choosing no odd number ball, right? And then we divide it by the total possibility of 12 choose 2. That's just how we do probability. And you work that out. See same 5 over 2 there? Oh, nice. So still get 5 over 22. So any method you want to do it, you get the answer. Nice. All right, so that's method 1. That's method 2. 5 over 22 is this right here. Nice. So we can just put that in. This is 5 over 22. Probability both balls are even. It says, what's the probability? One ball is odd and the other ball is even. Now there are three ways I can do this one. Well, to find the probability, you get one odd and one even, one odd and one even. Let's do it method one now, all right? Let's go method one. So the first way that we're going to do it now, method one, is if we stay so boom, bang, bang. To get one odd, what you need to do is, wait, let me change the color. To get one odd and one even, that means that can work out to be the probability, right? Or it's working out to be 1 minus the probability of getting 2 odd minus the probability of getting 2 even. O represent odd and this represent even. Yeah, that must give the probability of getting 1 odd and 1 even. Because remember, there are 4 possibilities. You can either get even and even if you draw 2 ball, or you can get even and odd, or you can get odd and even, or you can get odd and odd. So to get the probability of getting either a even and odd or odd and even, it's 1 minus the probability of getting 2 odd and 2 even. Yeah, man. So that's going to be 1 minus the probability of getting 2 odd, and the probability of getting 2 even is the same. So it's 1 minus 2 times the probability of getting even was 5 over 22. So that's also the probability of getting 2 odd, because it's an even number of balls. I hope that makes sense. And so it becomes this, 1 minus 2 times 5 over 22. And so what you do is then you work that out, you get 1 minus 2 into itself, 1, 2 into that 11, 1 minus 5 over 11, and that gives you 6 over 11, 6 over 11. Soft, that's method one. That's just method one. You don't have to do it this way. Let's look at method two. Method two. Let's change the color for each different method. For method two, which is probably the easiest method, the probability of getting 1 odd and 1 even, I'm going to write 1 O and 1 E. To get 1 odd and 1 even, you can say that it is just maybe you're choosing 1 even from the 6 times you're choosing 1 odd from the 6 and divide it by the total possibility, which is 2 choosing 2 from 12. So 6 choose 1 times 6 choose 1 over 12 choose 2, and you punch that in a calculator. So let me just change here. So the 6 choose 1 times 6 choose 1, punch that in the calculator, see there? 6 over 11, same thing. So any way you can do it, you're nice. That's the OR method, OR. All right, so those are the answer. All right, nice and easy stuff. You have another way to do it, right? Which is just the probability of getting 1 odd and 1 even. You just say it is the probability of getting odd then even plus the probability of getting even then odd. And you do it this way and you get the same answer. Any way you want to do it is up to you. So we get 6 out of 11. Can just punch that down there. That's the probability of getting 1 odd and 1 even. So them giving away marks here. Oh, nice. The next part now of section 3, by the way, them time your complex number, before 2012 complex number used to be in module 3. That's why they stay here. So find the complex number u such that u squared is negative 15 plus 8i, and u is x plus iy. So then give we say u squared is equal to, them tell us say u squared is equal to negative 15 plus 8i. That them tell us say is u squared. Yeah, man. So since this is u squared, then all you need to do now to find u, them tell us that at the same time u is equal to x plus yi. So if u is x plus yi, that implies that u squared, if you have to square both sides, you end up get u squared is x plus yi all square. Yeah man, u square is x plus yi all square. But at the same time, u square is what this? Negative 15 plus 8i. Negative 15 plus 8i is u square, yeah man. So since this is u square now, all we need to do is expand. And remember, when you expand, it's first term square, x square, plus twice the product of the two, which is 2x yi, plus second term square, which is yi all square. And that's going to be equal to the negative 15 plus 8i. Negative 15 plus 8i. Yeah, man. This is what we have. Since this is what we have now, we know that we can equate our real parts. So the x squared plus the yi all squared. This and this. If you're to expand this, it becomes x squared. This is going to then be minus y squared. Because look at this, the I squared, the y squared right here, so times I squared is negative 1. Yeah, man, so we end up equate real parts, equating our real parts. We have x squared minus y squared is equal to negative 15. So we have one equation. So it can lead to a simultaneous equation. Then we can equate our odd number parts now. The 2xyi equal to the 8i. So we can write equating imaginary. Equating the imaginary, what we have is 2x y is equal to 8. Now notice I drop off the I them. I drop off the I, because you don't need to say 2xi equal 8i. The I them cancel anyway on both sides. So from this second equation, that implies that if you make y the subject, y would be, divide both sides by 2x, y would be 4 over x. All I did was divide both sides by 2x. So this is y. If this is y, I'm going to substitute y into the first equation. So I'm going to sub, let's call it 2. I'm going to sub 2 in, and let's call this one 1. So I'm going to substitute equation 2 in 1. If I substitute equation 2 in 1 right here, plug in 2 in 1, this would become 4, well, x squared same way, minus y squared, but this is y. So y squared is going to be 4 over x all squared, and that's going to be equal to negative 15. This will be negative 15. So what we're going to get now is, this becomes x squared minus 4 squared is 16 over x squared. That's equal to negative 15. Now to solve this equation, we just need to multiply through by x squared. We multiply through by x squared. So multiplying through by x squared, you multiply through by x squared, we end up with, this become x to the 4 minus 16 is equal to negative 15x squared. All right, cool. Now what do you do next? You bring over to the other side. So we end up get x to the 4 plus 15x squared minus 16 equals 0. Minus 16 equals 0. So now what you can do is just do irregular factorizing, right? So this right here, x to the 4, yeah. You can always let y equal x squared, right? I'm not going to use y, I'm going to use m. Let m equal x squared. If you call in m x squared, this become m squared plus 15m. Then this become minus 16 equals 0. So what you can do now is factorize this and equate it to 0. Yeah, man. So then now this is now m. Signs are different. The bigger number, positive. So you write 16 and 1. the bigger number positive, minus here. So that good now. So that means m equal 1 or m equal, that look like negative 16. M equal negative 16. Now look at this now. When I get to here, so now if m equal 1, we're saying that x squared is equal to 1. And if x squared is equal to 1, we're virtually saying that x is equal to plus or minus 1. That is x plus or minus 1. If you have m equal minus 16 right here, then we're virtually saying that x squared equal negative 16. But that doesn't make no sense. X squared can't equal negative 16. So this one is not valid because you cannot square a number and get a negative number when x is real. Since x is an element of real number, we know this is not valid. All right, so x is equal to plus or minus 1. Since x is plus or minus 1, remember y was 4 over x. See it here, this was y, 4 over x. So y is going to be 4 over 1, so y is plus or minus 4. All right, nice. So that means that the complex number we get then is the complex number, what they call the complex number again? U. So the complex number u is equal to 1 plus 4i, that's one possibility, or the next possibility is u equal to minus 1 minus 4i. Those are the answer. Nice, easy, soft. Now, of course, I love to give verification. If you want to see a verification, look, remember we're supposed to get u squared is minus 15 plus 16i plus 8i. Look at this. If you have u squared, you'd have been squaring 1 plus 4i. This is just to verify your answer. If you have u squared is 1 plus 4i all square, if you expand that square, it's going to be first term square plus twice the product of the two, which is 8i, plus the second term square, which is plus 16i square. But 16i square is negative 16. Negative 16 plus 1 is minus 15 plus 8i. So no, so answer true. I'll get back what we're supposed to get. So sister, it's true. Nice. So now we can write down that u is 1 plus 4i or minus 1 minus 4i. So yeah, man, we can tell them. So that implies u is equal to 1 plus 4i, or we end up get u is 1 minus 4i. Minus 1 minus 4i, and we're done. Nice. Now it's a hence we're supposed to solve this right here. This little quadratic right here. So let me copy it. Let's copy it. Control C. We're going to do this question now. I shall it down nice and easy, man. No issues. So you have this question right here that you're supposed to solve now, and it's a hence. So this is z squared minus 3 plus 2i z plus 5 plus I. To do this, think of it as a quadratic. This is like your ax squared plus bx plus c equals 0. And you know, so when you're solving quadratics, you use the quadratic formula. So you need to remember the quadratic formula that x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. We need to remember the quadratic formula. All right? So what that means is all we're going to do now is this right here. We're going to then say z, because it's not x, it's z. So z is equal to minus b minus of minus 3 plus 2i is just 3 plus 2i. So that's z, 3 plus 2i, plus or minus the square root of b squared which is 3 plus 2i, 3 plus 2i, or this should have been a 3, 3 plus 2i all square, minus 4ac, minus 4 times a, which is 1, times c, which is 5 plus I, and all of that is being divided by 2 times a, where a is 1, so it's being divided by 2. So what that therefore means is that the complex number z is ending up to be equal to 3 plus 2i, yeah, 3 plus 2i, plus or minus, put my I, 3 plus 2i plus or minus. We expand the square root now to get 3 square is 9. So that gonna be 9 plus twice the product of the 2, that's 6i times 2, that's 12i, plus second term square, 2i square, that's 4i square, and 4i square is minus 4. All right, 2i square is 4i square. 4i square is minus 4. And it's minus 4 times 5 is 20. Then we have minus 4i. And this is all being divided by 2. All right, all being divided by 2. Nice. So now after we get that we know that the complex number z is going to be equal to 3 plus 2i, yeah, and then it's going to be plus or minus the square root of, we just need to simplify what's inside of here now. Simplify what's inside of here. 9 minus 4 is 5. 5 minus 20 is negative 15. And then 12i minus 4i is 8i. So you get minus 15 plus 8i divided by 2. Now look here, Go back to around here. Remember we said that u squared is equal to negative 15 plus 8i. U squared, what was u? 1 plus 4i. So if you square rooted both sides, the square root of minus 15 plus 8i would end up equal u. That's the square root of minus 15 plus 8i. U. What is u? U is what we found up here. U is 1 plus 4i. This is u. 1 plus 4i or minus 1 minus 4i. So that's what we're going to substitute for, the square root of this part. So now we're going to end up with z is 3 plus 2i. Then we're just going to write plus or minus 1 plus 4i. 1 plus 4i, and we divide it by 2, right? So we're going to get 2 answers for z now. First, I need to consider when it is plus. When it is plus, it's 3 plus 2i plus 1 plus 4i. And then this is being divided by 2, right? So we have to consider 2 of them when it divided by 2. So end up get that z is equal to 3 plus 4. Well, this was, why write 4 plus I here? My apologies, this was 1 plus 4i. 1 plus 4i. Giving it away. 1 plus 4i. So now is 3i. So z is 2 plus 3i. That's one possibility. Or the next answer is when you consider the minus. When you consider the minus, what you get is 3. Let me write it in black here. The 3 plus 2i minus, in bracket, 1 plus 4i. And this is being divided by 2. So when you do this now, what you'd end up get for z is 3 minus 1 is 2. 2 divided by 2 is 1, so that would work out to be 1. Then 2i minus 4i is minus 2i, minus 2i over 2 is minus I. So you get 2 plus 3i and 1 minus I. 2 plus 3i and 1 minus I. 2 plus 3i and 1 minus I. So that is z. Z equal 2 plus 3i or z equal 1 minus I. Nice. Now let's look at this question right here now. Question 6. Question 6 is a matrices question. It says solve this equation for x, the determinant equation. X minus 3, 1, and minus 1. All right. So we have that determinant equation to solve. The determinant of x minus 3, 1, and minus 1. 1 minus 1. And then now we have 1 x minus 5, 1, 1 x minus 5, and 1. And then we have minus 1, 1, and x minus 3. Minus 1, 1, and x minus 3. I will need to solve this determinant equal to 0. Now, to find the determinant, we're going to be using row 1. Using row 1, right? So using row 1, what do we know? What we know is that if we use row 1, we're using this guy up here. We're starting with this guy up here. Yeah? So if we're starting with that row up there, then we know it's going to be x minus 3 times the determinant of, you cross out the row and the column that have in x minus 3. That would leave us back with x minus 5, 1, 1, and x minus 3. Then it's going to be, remember, you have to remember your cofactor signs. It's then minus this element right here, 1, times, we look at the determinant now of when we cross out 1 and 1, leave us back with 1, 1, minus 1, x minus 3. So we have 1, 1, minus 1, and x minus 3. And finally, it is plus, but this is plus minus 1, so it's minus 1 times the determinant of cross out the row and the column with that one. We get 1 x minus 5 minus 1 and 1. So we get 1 x minus 5 minus 1 and 1. The determinant of that equal 0. So now to find this determinant now, it is just going to be x minus 3, and this is being multiplied by the determinant of now x minus 5 times x minus 3, x minus 5 times x minus 3. We multiply that, then minus 1 times 1 is 1. That's how we find the determinant of that. Then we have minus 1 times, in bracket, this is going to be 1 times x minus 3 is x minus 3. Close up that. Minus 1 make it become plus 1. Yeah. Then now we have minus 1 times, this is going to now be 1 times 1 is 1. Then it become minus, so it become plus x minus 5. I need to solve all of this equals 0. Now this seems like it'll be 1 cubic. We want to come take forever. We can't bother with that. Let's see now. So we need to simplify in the bracket in here. So it's going to be x minus 3 times. Look at the quick way you can simplify in the bracket. Remember, this times this would give us x squared. This times this would give us minus 3x. This times this would give us minus 5x. So it's just minus 8x. This time this would give us minus 15. But then minus 1 make it minus 16. Close up that. Then right in here, so now the minus 1, if you were to look at it, x minus 3 plus 1, this is now x minus 2. But then the minus 1 gonna make it just become minus x plus 2. Then finally this part now, 1 minus 5 is negative 4. but then the minus, make it become minus x plus 4, and this equal to 0. So now we have one more simplifying to do, which is to expand in this part now, and then we get a cubic equation. So that seems like a lot of work. X times all of this, then minus 3 times all of this, that's going to be x cubed. Going to be x cubed minus, that was 8x, and it's going to be minus 16x. Then we're multiplying minus 3 times everything. So just to go back, make you see, x times this is x cubed minus 8x squared minus 16x. Then you have minus 3 times x squared minus 3 times x squared. Then we have minus 3 times minus 8x, that is now just plus 24x. And then we have minus 3 times minus 16, that's plus 48. And we're good. And then remember right here, so now we have minus x is minus 2x plus 6. This is now minus 2x plus 6. So since this is what we have now, and it's equal to 0, what we know is that, look at this now, x cubed, put by the x cubed now, we have a minus 3x squared, that's the only x squared term. Wait, oh, that would be the only x squared term. That's crazy. X times this was x cubed minus 8x squared minus 16x. So I'm rubbing, this was minus 8x squared minus 16x. So minus 8x squared and minus 3x squared is minus 11x squared. Then I have minus 16x plus 24x, that's 8x, 8x minus 2x, that's 6x. This is then 6x. Then looking at my constants, I have, and at my constants, I have 48 plus 6 is 54. My God, this is going to be quite hectic now to solve because we end up with a cubic equation. We're going to have to use trial and error to find a factor. So I'm just going to go to my calculator just for a second. Let's open up the calculator and try to use trial and error for this one. X cubed minus 11x squared plus 6x plus 54. So we're going to use trial and error. Try value like 2. 2 cubed minus 11 times 2 squared plus 6 times 2 plus 54. See if that works. That's 30, so 2 don't work. Let's put negative 2. By the way, always try factors of 54. Let's try negative 2. Negative 2 don't work. Our next factor of 54 is what? 3. So let's try negative 3 first. You might say, sir, why you never start with 1? I have no idea. I just didn't want to start with 1. So let's try 3. Negative 3. Negative 3 don't work. Let's try positive 3. Positive 3 work. Nice. So now that positive 3 work, so let x equal 3. And we'll let x equal 3. We end up get the 0. We end up get x, we get 3 cubed. So you have to write it down in it, even though you use a calculator. To show them, say 3 cubed minus 11 times 3 squared plus 6 times 3. Yeah, man, you have to tell them, you have to tell them, you have to tell them. Plus 6 times 3 plus 54. You can tell them that this is indeed equal to 0. Since this is equal to 0 now, we're good. You can tick it because guess why? That means that x minus 3 is a factor. X minus 3 is a factor. Now, since x minus 3 is a factor, we can do our polynomial division. So I'm not going to do the division. I'm going to just do the division over here, and then we can write our answer under. So doing the division over here, we're going to divide x cubed minus 11x squared plus 6x plus 54, and we're dividing it by x minus 3, because that's the factor. Now that we divide it by x minus 3, x into x cubed goes x squared. X squared times x is x cubed. X squared times minus 3, that's minus 3x squared. We subtract. X cubed minus x cubed gone. Minus 11x squared minus 3x squared, that becomes minus and minus become plus. So that becomes minus 8x squared. Minus 8x squared plus 6x. So this into this now, x into minus 8x squared is minus 8x. And so then minus 8x times x is minus 8x squared. Minus 8x squared. And then this time this is now plus 24x. And then we subtract. After we subtract now, what we end up getting is 6x. Wait, something looks a little off because this won't give me 54. So let me go again. This time this is x cubed. X squared times this is minus 3x squared. Minus and minus become plus. Minus 11x squared minus this is minus 8x squared. And then I bring down the 6x. And then I say this into this goes 8x. This times this is minus 8x squared. This times this is plus 24x. Subtracting them, 6x minus 24. 6 minus 24 give me 18. Oh, I was adding wrong. That's like, why I got 0 right there? Minus 18x. So my apologies right there. All right. My apologies. So now we go like this now. X into minus 18x. That's negative 18. Then we stay, so now budung bang bang, x times minus 18, that's minus 18x. And then we have this times, this is now plus 54. And then when we subtract, we get 0, so we're nice. Now subtract them, we'll get 0. Yeah, man, now we're nice. Yeah, so end up with this now. So this that we're solving, we end up work it out now to be, this is what we're actually solving now. X minus 3. So you can write that implies that this from up here, that implies that we end up solving now x minus 3 times x squared minus 8x minus 18 is equal to 0. Can this be factorized? I know signs are 9 and 2. Can 9 and 2 work? 9 and 2, no, that wouldn't work. Let's go 6 and 3. That wouldn't work either. I'm not seeing the factors here, so I'm just going to use quadratic factor to solve this part. For this part, I'm going to say x is minus b, which is 8, plus or minus the square root of b squared, which is 8 squared, which is 64, minus 4ac, which is 4 times 1 times minus 18. It's divided by 2a. So I'll use quadratic formula for this one. And over here, we know that this answer is definitely just x equal to 3. So let's punch it in our calculator. That's why we have calculator. So it is minus b, which is 8, plus or minus the square root of b squared, minus 4 times a times c, divided by 2a of 2. No wonder we couldn't get it that way. It is 4 plus root 34 and then 4 minus root 34. Because if we change this to the minus now, if we change it to the minus, you get 4 minus root 34. Yeah, so those are the answers. So this can end up giving x equal to 4 plus root 34, comma, 4 minus root 34. Nice. So we're good. So of course, more I write all of the answer up on the paper now. So here it is. I'm gonna write it on the paper. So solving this, we end up get x equal to 3 or x equal to 4 plus root 34, or we end up get x equal to 4 minus root 34. Nice. All right, nice and easy, soft. Nice. All right, now look at this now. It says this is a matrix A and this is a matrix B. I need to find the matrix A times B, so we're just gonna multiply them across. Remember, this is just C-set maths now. We can quickly run through this to find the matrix A times B. So let's just write out what matrix A is. Matrix A, them give is 1 minus 1, 1, 1 minus 1, 1, and you have 1 minus 2, 4, 1 minus 2, 4, and then you have 1, 3, 9, 1, 3, 9. Cool, this is matrix A. I'll need matrix B. Matrix B is equal to, working out matrix B, 30 minus 12, 2. And then next you have 5 minus 8, 3. And then you have minus 5, 4, and 1. Nice. So this is it now. I will need to work out now the matrix A times the matrix B. So to work out the matrix A times the matrix B, we're multiplying 1 minus 1, 1, 1 minus 2, 4, 1, 3, 9. I'll multiply it by this matrix B over here, which is 30 minus 12, 2, 5, minus 8, 3, minus 5, 4, and 1. Nice. So we're going to multiply these now. So to multiply them, we know we'll go row by column, row by column. So multiplying them across, row by column, 1 times 30 is 30, minus 1 times 5 is 5, minus 5, 1 times this is minus 5, so I end up with 20. Now, if you don't feel as good computing in your head, use a calculator. Use a calculator, go 1 times 30 plus minus 1 times 5 plus 1 times minus 5. Then we'll go this row times this column, that'll become minus 12 plus 8 plus 4, which is 0. Then row by column, gonna give me 2 minus 3, 1, add them together, 0. Then we go row by this column, 30 minus 2 times 5 minus 10, 4 times minus 5 minus 20, add them together, 0. Then we go row by column again, minus 12, minus 2 times 8 is 16, 4 times 4 is 16. All right, not getting that again. This is minus 12, and this is 16, 16. All right, I'm just gonna punch that one in the calculator. Gonna punch this one in the calculator, multiplying the middles. All right, let me just bring out the calculator a little bit. All right, so bring over the calculator so I can see the two matrix them. So it's, I want you to see what I'm doing. So row by column, 1 times minus 12 plus minus 2 times minus 8 plus 4 times 4. Just do not make any mistake. That's 20. All right. This is 20. I was almost starting to make mistake. Then this row times this column, that's 2 minus 6, 4. Add them together, I get 0. Then following the pattern, I know it's going to be 0, 0, 20. All right, so that is A times B. So in reality, it works out that A times B is actually equal to, if you factor out 20 from this, it's 20 times the identity matrix I. That's A times B, 20 times the identity matrix I. Remember what is the identity matrix? The identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. That's the identity matrix. 20 times this matrix give you AB. All right, so we'll call it that now. All right. So again, just tell them say AB is 20 times I, where I is the identity matrix. Hence deduce A inverse. To find A inverse now, look at this. So we know say A times B is 20I, right? A times B is equal to 20I. So look on this now. If A times B is 20I, to find A inverse, if we want to find A inverse, we need 1 over A. No, we need 1 over A. So find A first. So if you station now and divide both sides by B, if we divide both sides by B, we end up get that this is saying that A is equal to 20 over B really, times the identity matrix I. If you flip this now, to get A inverse is 1 over. 1 over this would become B over 20, or we can write it as 1 over 20 times, when we flip it, it will just become B in the numerator, because it's now B over 20 times I. When you flip identity matrix, that's still just I. We can remove off the I part now. So this is A inverse, 1 over 20 times B. A inverse is 1 over 20 times B. Of course, many teachers will tell you to pre-multiply both sides by A inverse. I don't like to talk about pre-multiply, but A inverse is just 1 over 20 times B. Now, you don't just done this, so you can't stop right there, so please. Them say deduce it, so A inverse is going to be equal to 1 over 20 times matrix B. Look back what them gave for matrix B. So matrix B 30 minus 12, 2. So 1 over 20 times 30 minus 12, 2. Yeah. And the next row is 5 minus 8, 3. 5 minus 8, 3. Then the next row here so is minus 5, 4, 1. Minus 5, 4, and 1. So that is A inverse. So this is A inverse now. All right, I'll leave it at this. All right, we'll leave it at this for A inverse. Nice. All right. Now that we leave it at that for A inverse, it says now the last part, a system of equation is given by x minus y plus y, x minus y plus z, x minus 2y plus 4z, and x plus 3y plus 9z. It says express the system in the form ax equal b, then hence or otherwise solve the system. Express it in form ax equal b. Let's do part A right here. We know, so we're going to look at the coefficients of each of these terms. This column is the x column, so it's going to be 1, 1, 1. The y column, this is the x column. The y column going to just be minus 1, minus 2, and 3. The z column going to just be 1, 4, and 9. So that's what you have right there. And then you multiply it now by xyz. And this is now equal to 1, 5, and 25. 1, 5, and 25. Cool. So this is what we have now. Nice. So now after this is what we have, that's part A. But notice what is this? This is A. Yeah, man, this is A. Yeah? And since it says hence mean we're going to use from the inverse we found up here to help us solve this system. All right, so we have AX equal B. So what that means is when we express it in the form AX equal to B, right? So to find X, remember that X is going to be equal to A inverse times B. X is A inverse times B. So what we're going to do is we're going to multiply this by A inverse, and A inverse was what we found right here. This is what we found for A inverse, this right here. So it is just going to be 1 over 20 multiplied by all of this around here. And what did we have? Yeah, man, we had 30 minus 12. And that was what again? That was 2. Then this is now 5. What was that? Minus 8, 3. And then right here, so we have minus 5, 4, 1. Minus 5, 4, and 1. Nice. And then we'll multiply it by the matrix B. Matrix B is going to be from this right here. This is B, the small b, 1, 5, 25. 1, 5, 25. Yes, I just some C-sec maths this. And now we're going to simplify. So X now is 1 over 20 multiplied by, it's going to be row by column. 30 times 1 is 30. Then minus 12 times 5, that's 30. Minus 12 times 5, which is minus 60. 2 times 25, which is 50. Then row by column, that's 5. That's minus 40. Then 3 times 25 is plus 75. Then finally, it's going to be row by column, which is minus 5, plus 4 times 5, which is 20, plus 1 times 25, which is 25. All right, and so what this works out now to be is 30 minus 60 is negative 30, plus 50 is 20. But then the 20, well, let's not jump the gun. So we have 1 over 20. This is multiplied by 20. And then this right here is 5 minus 40 is negative 35, plus 75, that's 40. And then this down here is negative 5 plus 20 is 15. 15 plus 25 is 40. And so to finish it off, we end up get that this work out to be 1 over 20 times 20 is 1. 1 over 20 times 40 is 2. 1 over 40 times 1 over 20 times 40 is also 2. So that end up tell we say this is a x, this is a y, this is a z. So that means that x equal 1, y equal 2, and z equal 2. All right, nice and easy. That's what that's saying right there. So you can check it now. So we just get our answer. The answer we get is x equal 1, y equal 2, z equal 2. And as I said, if you don't believe it, we're going to check it. Let's go check this. Checking it, so punch it in the calculator. 1 for x minus z, which is minus y, which is 2, plus z of 2. You get, see there, you get 1. Checking it in the second equation. 1 minus 2 times y of 2 plus 4 times z, which is 2. You get 5. See there? Answer right. Check it now, last one. 1 plus 3 times 2 plus 9 times 2. You get 25. See it there? So now say it right. And we're done. Nice. So that's it. That concludes module 3. Nice.